Hallo, dieser Podcast wird Ihnen präsentiert vom IT-Dienstleister Adesso. Mehr über das Unternehmen unter www.ki.adesso.de/Industrie. Viel Spaß beim Zuhören.
Hallo, liebe Zuhörerinnen und Zuhörer, das ist die Podcast-Folge Nummer 79 des Podcastes KI in der Industrie. Mein Name ist Robert Weber, ich sitze im Würzburger Homeoffice und mir virtuell gegenüber sitzt in München
Peter Seeberg. Guten Morgen, Robert. Schönen Gruß an unsere Zuhörer, Zuhörerinnen zur ersten Folge in diesem Jahr.
Zur ersten richtigen Folge sozusagen, wo ihr uns beide hört, weil wir hatten ja schon eine.
Ersten richtige, genau. Erste, die wir jetzt mit aktuellen Teil aufnehmen, so ist es gemeint. Ja.
Wir haben heute, aktueller geht's eigentlich nicht, wir haben heute den Calvin im Interview. Der hat ein Unternehmen gegründet, Conductiv.ai, für AI in der Semiconductor-Produktion und der erzählte später, da hören wir gleich rein, der erzählt, er ist ein Trump-Flüchtling, der ist also abgehauen, als Trump Präsident wurde und jetzt haben wir ihn im Interview. Ja? Also die letzten Tage der Präsidentschaft Trump sind angebrochen und jetzt haben wir auch noch einen Trump-Flüchtling in unserer Folge. Ja, sehr spannend. Was hast du im aktuellen Teil, Peter?
Ja, bei mir geht's zuerst um Daten in der Form von Zahlen, nämlich die Erkenntnis, um mal mit Daniel Kehlmanns Vermessung der Welt, der ein oder andere, der das Buch gelesen hat, ich hab's noch nicht gelesen, werde es vielleicht noch machen, aber normalerweise finde ich die Ruhe nicht dafür, so viel Zeit da reinzustecken. Aber es geht um die gewachsene Bedeutung in unserer Gesellschaft von Daten und Zahlen. Daten, also die Grundlage, wie wir alle wissen, für maschinelles Lernen, für KI, vorangetrieben in diesem Fall durch Corona. Also unser Alltag wird ja immer stärker, nicht ungleich, hätte ich gesagt, KPIs, also Key Performance Indikatoren, die wir alle, die meisten von uns zuhören in den Firmen, in unseren Firmen, aber auch in unseren Anlagen, ob es jetzt geht um Umsatz pro Woche, pro Mitarbeiter, pro Monat oder bei den Anlagen Ausschuss, täglicher Ausschuss, monatliche Leistung und so weiter, ist auch immer stärker unser Leben durch Zahlen bestimmt. Ganz wichtig in diesen Tagen ist halt eben der Inzidenzwert, der bestimmt, ob wir in die Stadt einkaufen gehen, ob wir ins Wirtshaus, ob wir ins Kino, Theater, wird noch ein bisschen dauern, und aber auch konkret, ob wir unsere Kinder in die Schule schicken können oder zu Hause oder anders wie betreuen. Und mittlerweile, in welchem Umkreis wir draußen uns bewegen dürfen. Ja, ich habe mich selber im letzten halben Jahr befasst mit dieser ganzen Geschichte. Der eine oder andere hat sich auch schon mal gefragt, was bedeutet denn eigentlich logarithmische, exponentielle Entwicklung? Hat sich dann vielleicht hier oder dort erklären lassen über das Moore'sche Gesetz, immer noch die beste. Im Endeffekt, ich habe hier da angefangen, ganz am Anfang, habe da so eine kleine Grafik aufgehängt in der Küchenschranktür bei uns zu Hause. Angefangen beim halben Punkt pro 20.000 Bewohner, dort wo ich halt wohne. Und ich hatte eine Erwartungshaltung auch eben, dass sich diese Geschichte logarithmisch entwickeln wird. Das war dann bis heute nicht unbedingt, vielleicht ab und zu mal teils, aber dann doch nicht so stark. Als es dann ging um diese Wirkung von Tests und Impfstoffen, hat sich sogar der eine oder andere an statistischen Begrifflichkeiten wie Sensitivität oder Spezifität gewagt. Ich werde jetzt nicht darauf eingehen. Ich habe in der Vergangenheit bei der Firma Intel schon immer gelernt, dass Ziele messbar sein müssen. Ich schaue täglich, wie viel positiv Getestete pro 100.000 es bei uns gibt. Und so richte ich meinen Alltag darauf ein und immer stärker in den nächsten Tagen. Ich glaube, ab morgen, wenn wir das jetzt hören, sind wir ja mittendrin in den verstärkten Lockdown. Und dann werde ich auch wissen, wie weit ich von zu Hause gehen darf. Also der Punkt ist, Daten, Zahlen, die sind nicht nur für maschinelles Lernen, für KI immer wichtiger, aber bestimmen auch immer stärker unseren Alltag mit allen positiven, möglicherweise auch negativen Folgen, die das hat.
Genau, und es wird spannend sein, was davon dann am Ende des Tages bleibt. Ob diese Zahlen, Daten, faktenbasierte Analyse bleibt oder ob sich das wieder ganz schnell verhindert. Es gibt ja auch Leute, die sagen, wir schauen viel zu viel auf diese Zahlen. Gibt es ja auch andere Meinungen zu dem Thema. Ich habe nur ganz spannend vielleicht gesehen, um das Thema einmal noch zu stressen, die logarithmische Entwicklung in London, sowas habe ich noch nie gesehen. Also
Und
wie das
tatsächlich eine logarithmische im Sinne von Woche auf Woche oder?
ja, also sowas habe ich noch nie gesehen. Wahnsinn.
Ja, wir wollen jetzt nicht zu stark Richtung Corona, aber ja, genau so ist es. Und ich habe da noch heute Morgen sogar in der FAZ, in der FAZ, gibt es so einen Teil, wie erkläre ich es meinem Kind? Und da wird aber auch über den negativen Teil weil was bedeutet jetzt eine Zahl? Und wie wird diese Zahl erkundet? Und diese Zahl, die dann jetzt in den letzten Tagen aus unserer Weihnachtszeit resultiert hat, ist halt eben nicht dieselbe Zahl oder nicht direkt vergleichbar mit den Zahlen vorher. Ja, schauen wir mal. Aber ich denke, dass tatsächlich dadurch, dass wir als Gesellschaft auch immer stärker uns mit KI, maschinelles Lernen, immer mehr Leute, wie wichtig die Zahlen sind, ich glaube, werden wir uns immer mehr damit beschäftigen, auch mit den negativen Seiten, eben dafür zu sorgen gemeinsam, dass diese negative Seiten der Zahlen so wenig wie möglich auftreten.
Sehr schön. Ich habe noch was Positives mitgebracht und zwar Ende letzten Jahres, also kann man ja schon sagen, Ende 2020, gab es eine Meldung, nämlich Festo hat seine Reinforcement-Hand, nicht seine Hand, sondern die haben im Prinzip die Software Open Source gestellt für diese Softwarehand. Wir haben gerade im Vorgespräch gesagt, Peter, vor 2 Jahren, glaube ich, zu Hannover Messe haben wir die Nason-Freunde, den Jan Kautnik, getroffen und der hat uns das erklärt. Ich weiß nicht, welche Folge 10 oder so. Und jetzt ist dieses Softwarestück dieser Hand, dieses Reinforcement Learning dieser Hand Open Source verfügbar. Ich referiere nochmal auf unsere Folge 69 zum Thema Open Source und KI, was man da beachten muss, wie das geht. Aber klar, diese Hand war halt auch eine Spielerei, so wie viele andere Dinge bei Festo auf Messen oft Spielerei sind, dieser Vogel oder diese Elefantenrüssel. Aber spannend, dass sie das jetzt Open Source stellen.
Ja, genau, das war die Folge 6. Derjenige von Ihnen, der oder die das nochmal nachhören möchte, ist fast 2 Jahre her, unglaublich, ne? 17.04.2019. Und das Interessante, warum wir das damals gemacht haben, und damals gab es ja noch die echte quasi Hannover Messe. Ich separat haben wir, glaube ich, dann den Jan auch besucht und mit ihm damals schon geredet. Es ging darum, dass der Jan, der ja Kollege von Jürgen Schmidhuber, die ICA, ein auf Reinforcement Learning, also bestärkendes Lernen, damals noch ein ganz, ganz neuer, immer noch ein sehr neues, sehr vielversprechender KI-Ansatz. Und die haben damals für und mit einem Team von Festo diese Software für diese Hand entwickelt. Ich habe das ja auch geteilt auf LinkedIn und ich muss sagen, die Reaktionen, die waren von auf der einen Seite, ja, wieso, nichts Neues, das macht der Microsoft seit 10 Jahren so ungefähr, hat die eine Gruppe gesagt, aber die andere Gruppe hat gesagt, ob das aber mit diese Entwicklung, diese Open Source, wo der eine gemeint hat, es hat doch oft, wenn es auch um diese Gabel geht, ne, diese Forks, also ich habe eine Entwicklung und der eine oder andere sagt, aber diese Entwicklung, die da jetzt losgeht, die ist doch nicht so, wie sie sein soll. Gehen wir mal einen Schritt zurück und dann machen wir einen neuen Gabel auf. Der hat gemeint, dass man, ob das die Frage gestellt, ob das dann mit KI, mit Modellen überhaupt möglich sein wird. Also ich denke, wir sollen es weiter verfolgen und ob das so ist, wir haben schon drüber gesprochen, dass es auch möglicherweise neues Geschäftsmodell geben könnte, wo Modelle entwickelt und Modelle quasi vermarktet als Service angeboten werden.
Genau, das hatte der Sepp Hochreiter in der letzten Dezemberfolge uns mitgegeben, dass er gesagt hat, das könnte ein Wachstumsmarkt sein für Unternehmen, Modelle anzubieten, so wie GPT-3 und daraus rausnehmen und da im Prinzip dann ein Few-Shot Learning draufzusetzen. Ja, spannend. Was hast du noch, Peter?
Ich habe einen Punkt. Derjenige von Ihnen, von euch, der Interesse daran hat, auch mal autonom zu fahren, der kann das machen quasi eine Stunde lang von nördlich von München, fängt an in Unterschleißheim, der eine oder andere, der sich auskennt, durch den Münchner Norden in einem Ford-Fahrzeug durch BMW-Territorium. Der Norden Münchens ist ja geprägt von BMW-Gebäuden, da steht ja auch das Hauptgebäude, der Zylinder. Und dann geht's wieder zurück nach Unterschleißheim. Und interessanterweise ist mit Technologie sehr wichtig, der israelischen Firma Mobileye, das ist eine Intel-Tochter. Und man stellt das Auto dann ab auf dem Parkplatz vor dem Gebäudekomplex BMW Autonomous Driving. Ich will damit gar nichts sagen. Ich weiß nicht, ob es mit BMW zu tun hat oder nicht. Wie gesagt, fahren tut man in einem Ford. Sehr interessant. Ist nur mit Kameras ausgestattet, dieses Auto. Es wird vorher erklärt, also so wie eigentlich nur der Elon Musk, der Tesla-Mann, das tatsächlich auch vorhat. Alle anderen Anbieter, auch die Mobileye, haben vor, zusätzlich dann noch diese Fahrzeuge mit Radar, mit LiDAR-Systeme auszurüsten. Es geht hier offensichtlich um eine Testsystem. Es geht nicht in die Innenstadt, was ich gedacht hatte. Sie sagen, wir fahren München, aber Sie fahren nicht in die Innenstadt rein. Ich glaube, dass es wichtig ist für den Stand der Dinge. Der Fahrer, der sitzt hinterm Lenkrad, Hände griffbereit auf seinen Knien, greift aber kein einziges Mal ein und es geht über die Hauptein- und Ausfallstraßen, wie gesagt, im BMW-Territorium. Was sieht man? Man sieht die Bilder der Frontkamera. Man sieht, was der Algorithmus daraus macht. Das ist natürlich das Allerinteressanteste. Ich kann da wählen zwischen Frontansicht oder auch Vogelperspektive, wo ich mich quasi über meinem eigenen Auto befinde. Ich sehe eine geschätzte, ich weiß nicht, 100 Meter vor dem Fahrzeug. Also der Algorithmus, der sieht 50 bis 100 Meter, sieht er die Autos, die vor einem fahren. Er sieht, was links von uns ist, ne, auf der gegenüberliegenden Fahrbahn. Er sieht rechts von uns, was auf der Fahrbahn dort ist, vielleicht geparkte Autos, Fußgänger und so weiter. Ja, es funktioniert alles gut. Es gibt weitere interessante Momente. Es gibt ein kritisches, würde ich sagen, Einparkmanöver. Es fährt einer vor uns raus und der geht dann auf die Bremse und setzt dann wieder zurück. Ist auch im normalen Leben für einen menschlichen Fahrer nicht so einfach, abhängig wie schnell man das erkannt hat, kommt der Fahrer noch gerade noch so rein und ich habe gedacht, jetzt muss der Mann eingreifen, muss er gerade nicht. Wir stehen auch mal hinter einer Feuerwehr, sehr interessant. Das dauert dann so vielleicht eine halbe Minute, bis dann die Autos, die hinter uns sich aufgestaut haben, anfangen uns zu überholen. Quasi 2 oder 3 Autos und dann folgen wir quasi. Und sehr interessant, einmal kommt eine Person, stellt ein Auto rechts von uns ab, geht raus und macht die Tür auf. Und dann sieht man sofort, wie das Lenkrad quasi so im Ruck so nach links geht. So eine direkte Reaktion. Alles in allem würde ich sagen, klasse Leistung. Es ist sehr interessant. Man muss es ja nicht eine ganze Stunde machen, wie ich das gemacht habe. Ich wollte wissen, wo Sie fahren. Und ich denke, dass es sehr gut den Stand der Dinge repräsentiert. Zur gleichen Zeit, zum Abschluss, habe ich heute Morgen noch gelesen, dass der Waymo-Chef, also diese Google-Tochter, der Kraftschick heißt der, glaube ich, der hat jetzt gesagt, autonomes Fahren sei schwieriger als einen Raketenflug, auf wen er dort wohl deutet. Und die sind ja auch schon sehr weit gekommen, aber er will damit natürlich auch ganz klar sagen, noch sind wir nicht so weit.
Sehr spannend. Wir packen das Video oder den Link des Videos auch in die Shownotes rein. Hat auch einige Diskussionen bei dir auf LinkedIn gesorgt, dieses Video habe ich gesehen.
Ja, genau.
Ich habe auch noch was für die Shownotes, nämlich ein interessantes Paper, jetzt kommen wir wieder zur Industrie, nämlich ein Paper, ein Referenzarchitekturmodell für Industrial Edge Computing, basierend aufbauend auf die RAMI 4.0 für die Plattform Industrie 4.0 und da geht es darum, die Aspekte 5G, TSN, KI, OPC-UA, PLC-Programming im Kontext von Edge Computing. Packe ich in die Shownotes, ist bei IEEE veröffentlicht worden, könnte man nachlesen, ist spannend, glaube ich, für unsere Industrieanwender. Und dann habe ich noch was, die TU Darmstadt hat nämlich eine spannende Anwendung präsentiert, oder Forscher von der TU Darmstadt, ein Neural Howard Computing. Und es geht darum, neuronale Netze, kennen wir ja, lösen gut spezielle Aufgaben, aber im Gegensatz zu Menschen können sie einmal gelernte Strategien schwer auf andere Aufgaben übertragen. Und die Forscher der TU Darmstadt sind jetzt davon überzeugt, dass sie das geschafft haben, dass auch eine Übertragbarkeit stattfinden kann. Und ich mache einen Link auch noch zu dem Paper der TU Darmstadt.
Wie heißt der? Ein Howard Computer oder wie?
Neural Howard Computing.
Mhm.
Ja.
Interessant.
Ja, sehr spannend. Und jetzt kommen wir zu unserem Hauptteil, zu einem Hauptteil, den habe ich dir überlassen, weil es dein Leib- und Magengericht sozusagen ist, aus deiner Intel-Vergangenheit. Jetzt stresse ich mal das Wort. Es geht um die Produktion von Semiconductern und die Frage, wie Machine Learning oder künstliche Intelligenz dort Menschen und Maschinen unterstützen kann. Und du hast mit Calvin Ng ein Interview geführt, und Calvin kommt, wie wir schon am Anfang gesagt, aus den USA und hat in Berlin gegründet. Und ich fand, als ich das reingehört habe, Peter, einfach einen sehr angenehmen, netten, gut erklärenden Interviewgast.
Ja, wo du das so sagst, hat er mich schon zurückgebracht. Ich hatte mir nicht mal vorgenommen, diese eine Firma, wo ich dann so lange gearbeitet habe, in diesem Jahr nicht mehr zu nennen, aber ja, hat mich schon zurückgebracht quasi ins Silicon Valley. Sind bestimmt immer noch sehr viele Asiaten und ein bestimmter Typus, würde ich sagen. Wenn ich jetzt dran zurückdenke, ist schon ein paar Wochen her, das Interview, was ist mir hängen geblieben? Tatsächlich Nummer 1, du hast es anfangs erwähnt, er ist quasi seinem Land als Amerikaner entflüchtet vor 4 Jahren. Und ich sehe da eine kleine Parallelität quasi. Der ist, und da werden wir in den nächsten Wochen auch noch drüber sprechen, wie andere Kollegen dann ganz bewusst Berlin ausgewählt haben. Er ist geflüchtet, er kommt irgendwie nach Berlin und überlegt sich dann, was er machen will, also nicht umgekehrt. Das ist sehr interessant, und daraus entsteht diese Firma, die sich halt mit Data Science, mit Machine Learning, mit KI für eben die Halbleiterindustrie beschäftigt. Das ist, du hast recht, mein altes Metier, nicht unbedingt jetzt auf der technischen Ebene, obwohl ich auch die eine oder andere Fabrik damals besuchen durfte und schon ein bisschen den Prozess verstehen sollte, weil ich das den Menschen, den Anwendern näher bringen sollte. Es gibt viele Begrifflichkeiten, die nicht direkt in unserem klassischen Produktionsmetier zu Hause sind, aber sehr interessant. Es geht auch dort wieder darum, dass, was wir bei uns ja die Gesamtanlageneffektivität nennen, in dem Bereich der Halbleiter, der Chip-Produktion zu verbessern, unterm Strich. Und ja, sehr schönes Interview mit ihm.
Genau, und wir haben das Interview in Englisch geführt, und wir werden das Interview jetzt nicht unterbrechen, sondern das in einen Flug sozusagen durchlaufen lassen, weil es immer schwierig ist, von Englisch in Deutsch dann wieder zu switchen. Und fürs Zuhören ist es, glaube ich, einfacher, wenn man es in einem Stück sich dann anhören kann, weil dann ist man einmal in der Sprache drin, hat sich reingehört. Und ich wünsche jetzt erstmal informatives Zuhören mit Calvin Ng und Peter Seeberg zum Thema Machine Learning KI in der Semiconductor-Industrie.
Good morning, Calvin. Very nice you're with us. Please introduce yourself to our listeners. Who are you? Where are you from? What have you been doing so far, and what it is that you do today?
Mm-hmm. Hi, Peter. Thanks for having me. Very excited to be here today. So my name is Calvin. I'm the founder and CEO of Conductiv.ai. So I'm originally from San Francisco. My background is in materials engineering. Before founding Conductiv, I was at Applied Materials, and I worked on bright field inspection and e-beam metrology. And while I was at Applied Materials, I got the opportunity to work with some of the largest semiconductor fabs around the world. However, when Trump got elected, I decided to leave America. So I guess you could consider me one of those Trump exiles. So I took the time to travel around the world, and I settled in Berlin to start a company. So that's how Conductive AI was born. So what we've been doing is we've been working with companies here in Europe, semiconductor fabs and research institutes, to help them improve production yield and to reduce their time to market for their semiconductor products. And so today we're assembling a larger team and we're doing fundraising for our company.
That sounds great. You have introduced yourself as Calvin. You didn't mention your family name. Please do, because I've got a specific question related to your family name.
Well, my last name is Ng.
There you go. Well, that's what I needed to hear, because, and now the question comes already, and I'm sure that many people ask you, if we talk about künstliche Intelligenz, artificial intelligence, there is this famous person with the same family name, which I, in the past, never knew how to pronounce it. So I think I heard you say Ng, and the person I talk about in this case is Andrew. So, and the question then, of course, is, are you in one or the other way related to the Coursera co-founder?
I'm sure we have some relationship, somewhere in the history, but unfortunately, we're not directly related. But I always tell people that we are, somewhat related.
Somewhat, yeah, okay. Is that an Asian name in most general terms speaking, or?
Yes, specifically, it is Cantonese, so it's from Hong Kong, southern China.
Very good. Thank you very much for that. So thanks for that general introduction. Maybe immediately reacting here to you suggesting that you are from San Francisco. I've been spending some time in the Valley with Intel. We may be talking about them today or not, but the theme today is artificial intelligence and semiconductor manufacturing. Mm-hmm. But before I forget, so you say you left San Francisco for specific reasons that we don't discuss here in further detail politically. But I immediately thought of another company which is based in Berlin today, which is called Merantix. I don't know if you've heard of them. So they are a shop, setting up in very many different markets AI activities. And I learned from them that, and they are German guys originally who lived for, I don't know how long, in San Francisco. And they then decided to come to Berlin for the reason that, with the thing that they want to do, they were going to be in a city that attracts people locally. And that's why I thought of you. You somehow came to Berlin and then decided to start your company. So maybe talk about a little bit about what is your company, Conductive.ai, and maybe the link, if there is at all, to Berlin, why your company is based in Berlin.
So it's actually quite interesting that me and my co-founder, we met in Berlin because I'm a U.S. citizen and he's a Russian citizen. So we met, next to the Berlin Wall. So one of the reasons why I decided to come to Berlin to start a company is because it's one of the up-and-coming startup, basically, capital in Europe. And it's very cheap in terms of the living costs. When you compare to San Francisco, it's basically, living here. I'm living here almost, for free. So it's one of those places where you meet a lot of people. There's a huge diversity of talents here. And especially with the universities around here in Berlin, there's a lot of talents. There's also a lot of startup already. So there's already an ecosystem here that is set up to support new companies. The German government and the local government here in Berlin, they're also very supportive of startups. For example, Berlin Partners, they help us a lot, basically expedited the process of getting our entrepreneur visa here. So we've gotten a lot of support from the local agencies. So basically what we do at Conductive AI is we use a mixture of machine learning and physics-based simulation to reduce the time to market for semiconductor and other precision manufactured products. And we're using a variety of enabling technology, such as automated machine learning, federated learning, and explainable AI.
Sounds great, and we'll come to talk about any of those in a couple of minutes. And when I hear reduced time to market, I must think back to my time with Intel here in Europe, close to where I'm living right now in the Munich area. And then, whenever we did whatever, I started with 486, I believe, and at some point in time Pentium, and the job was always to increase the speed to time to market, or in your words, reduce time to market. So getting into a little bit more detail than what your company does, you talk about zero interaction manufacturing or self-perfection process control. What do you mean by that?
Yeah, so zero iteration manufacturing basically means getting it right the first time. So in the semiconductor industry, there's a very long ramp-up process. So even when you have a design that's already ready, you still have to figure out what exactly, the temperature, what exactly the pressure to produce these chips. And you have, 400, 500 steps along the way. Each of those steps, you have to come up with a recipe. So that means getting it right the first time is not something that is currently being done. Right now, it's like getting it right after, 6 months or 9 months. So basically what we wanted to do ultimately is to be able to get the recipes right the very first time, so that we can basically skip that very, very long ramp up process. And self-perfecting process control basically means having somewhat like a cyber-physical digital twin that can be able to withstand the process shift, the process drift that happens within the production line. And there are lots of ways how they can shift and drift. So each manufacturing tool, they have their own maintenance history, and each of their chambers, they can degrade in a different manner. So things are always shifting around. So things are always happening in the production line, and being able to self-correct and self-perfect, that's something that we really, really need to be able to avoid these shifts and drifts.
Sounds great. Getting it right the first time is, as you say, you talk about sometimes 6 months, maybe sometimes short, I don't know, maybe not, maybe sometimes longer, I believe. And then again, I'm being kind of thrown back into my past, where at that time, CEO Craig Barrett, and that was not about getting it with the new chips, but when there was a fab that was producing at a certain process, he was always talking about copy exact, I believe, as it was. So the next factory was going to be, if possible, a 100% exact copy of the process of everything. You will talk about that today. And at the same time, having said that, I'm not into the detail of semiconductor manufacturing these days, but I hear that, for example, Intel has been taking a little bit longer than usual with their latest process. So I assume that is kind of the environment in which you're working in. I mean, not necessarily with this one company, but just as an example. So tell us, what are the critical factors to determine the success of a semiconductor fab?
So there are basically three. So the first one is obviously yield. So yield is basically defined as the percentage of chips that pass the quality test. So anything that is, below 80, 90%, that is not profitable to the fab, because they're throwing away, if you're at an 80% yield, that means you're throwing away 20% of the chips that you produce. Yeah. So produce each chip, you are using a lot of energy, you're using a lot of material, you're using a lot of processing costs. So the yield is one of the most important factor. The other one is throughput. So how fast you can get this blank wafer to a bunch of chips. So obviously, the faster, the better. The last factor is obviously cost. So how much, let's say, how much material you use. There's also, chemicals that are fluctuating in price. So the formulation of your recipe sometimes would need to change based on that. And there's also the cost of, labor, the cost of processing. So lots of small factors go into cost.
Sounds a lot like the more general term of OEE, like original equipment efficiency. Not sure that is being used in the semiconductor market. Have you heard of it? Do you use it or not?
I have not heard of it.
No, right. So it's probably more in a different, excluding then semiconductor manufacturing, where maybe you have your own kind of KPIs, but it's very similar, looking at, can I change throughput? Can I make sure what you call yield, at the end of the production line? Mm-hmm. And when you say 80-90%, I'm not sure where that number typically lies. It's probably always dependent on where you are in the life cycle, etc. But of course, there are certain production processes. If you say, certain pieces of a car where that yield has to be more like, 99.94%, something like that, which is then, of course, a lot easier because we're talking different production processes. But the idea is always the same, to make sure that you get the maximum, a minimum, and then at the same time, a maximum of good quality, okay quality product out of your line at the minimum cost. So how does your approach then maybe differ from most other process control software solutions that are used in fabs today?
Mm-hmm. So there are two big differentiating factors that sets us apart from other process control softwares. So the first one is unified decision making. And this is different from what's the conventional silo decision making. So what I mean by unified decision making is that we basically make a decision for all 400, 500 steps along the entire production flow at the same time, versus having a silo decision making process coming up with individual recipes for each of the production steps. So the reason why we do this is because there's currently in the semiconductor industry, when you make decision based on silos, you have to deal with a lot of integration. So there's already a very large integration department in these fabs that are dealing with, coming up with a compromise between your steps and making sure that there are no downstream defectivity that are coming up, a few steps after a recipe change. So what we're doing is basically we want to use a holistic approach to this, decision making. We want to come up with a meta recipe that can include the small step recipes all at once. So the second differentiating factor is that we can actually predict line level KPIs. So instead of just checking the number of defects after each step, checking the metrology metrics after each step, what we want to do is actually predict the yield, predict the cost, and figure out the throughput for the entire line together. So what this means is that each step you are contributing to somewhat to the yield, and you're contributing to the cost, and being able to figure that out and predict what's going to happen at the end is going to make a huge difference.
Yeah, sounds great. It reminds me also, so the second one specifically speaks to me, so to say. So what you're saying is that you will find out if any kind of problem at, let's say, stage 3 of a line, what influence it has on a potential problem in stage 15, and how in the end it will turn out to influence the yield, for example, right? Is that what it is that you're doing?
Yes, absolutely. And one thing I did not mention is how it differs from most conventional, let's say, process control software. Mm-hmm. Since we are predicting line level KPIs, it's completely different from the approach of, reactive process control. So reactive process control basically means you have a dashboard and you basically look for, spikes in your SPC charts. So if you have, a spike of, defects or some metrology values that are going out of control, then you go back and you make changes to your recipe. So that's a very reactive approach that they're taking. And what we're doing is we want to do it in a very predictive and proactive manner. So this is what our second differentiating point is.
Yeah, very good. And that's what's typically being done in a number of industries that we've been following so far, and specifically in discrete manufacturing, to which I would or would not, I'm not sure. I'm not sure how much of, if we differentiate between discrete and process manufacturing, I mean, there's a lot of fluid and gas and stuff involved, I assume, in chip manufacturing as well. But in the end, what comes out is a discrete piece, right? Is a wafer to be cut into, I don't know, tens or hundreds of different chips. But this approach, of which we have had for, I guess, about like 20 years, called condition monitoring, looking, what is happening. Oh shit, something goes wrong. Moving into to a machine learning based predictive approach. I need to see if certain values are reaching whatever these spaces here, then something is going to happen in the next 10 minutes. That's what we see happening as well. And that's very interesting to hear from you, that you confirm, maybe with minor different terminology, that you're doing the same thing for your customers. You already mentioned two specific approaches, technologies, federated learning, which we talked about a couple of weeks ago, and AutoML, which we have been using about here as well. But just in your words, what are they, and what do you use those approaches for?
Mm-hmm. Yeah, so federated learning is basically a subset of decentralized learning, or you can call it distributive learning. So being able to basically build a model based on data coming from many different sources, but not inside one silo. So one of the reasons why we need this in the semiconductor industry is because we're dealing with a lot of different tool vendors. So you have processing tools from Applied Materials, from KLA, from Lam Research, and they're all competitors. They're not willing to share their data with each other. They're also not willing to share their data with the fabs themselves. So it's very, very hard to optimize for the line level KPIs without these raw data. So federated learning is the perfect solution for this, because we can actually implement it so that you don't have to pull all your data together in one silo. You can build a model for the entire production line without having all the data together. So that's federated learning. And AutoML is also very important to us because, as I mentioned before, with the process shift and the process drift that are constantly happening inside these production tools, inside these chambers, it's very, very hard to build one model, every a few days, every week. It's basically impossible to do that when you have a few hundred chip designs going on, and you have many, many, many production lines inside a fab. So automated machine learning allows us to quickly adapt to the changes that are happening in production in real time and adjust the models that are being used. And this is one of the cornerstone for self-perfecting process control.
That sounds really great. So federated learning, yes, as we've discussed it, which is like, GDPR positive, so to speak, which is not such a big of an issue normally in manufacturing. It's more of a topic in consumer space, right? But so federated learning, allows you or facilitates you to deal with data that include personal data from humans. You say, you have a similar topic, but in your case, it's about so many organizations being involved, and they all sit on their own data, but maybe they allow you to look at the data as long as you keep them at their side of their piece of the equipment, is my understanding. And AutoML, Also very interesting. So you see, it allows you to adapt easier, to more easily adapt to changes. Quickly, one more question there. How far are you then with AutoML today? We typically have this discussion today that we see a lot of research going on. There is a big research here in Germany with Google happening, but you actually have, solutions running on AutoML today, or?
Mm-hmm. Yeah, so actually we already have a MVP using automated machine learning that's able to do algorithm selection and also hyperparameter selection. So, when you have a data set and you import it into our MVP, we can actually figure out what's the best algorithm to use, figure out the best neural network structure for it, and come up with the hyperparameters that are most suitable for this particular data set.
Very good. Do I or listeners find more information about this on your website, or not today, maybe in the future?
Yes, absolutely in the future. So
Okay.
we're in the process of revamping our website. Right now, it's a very, very minimalist page.
Okay. That's okay as well. You already have an MVP, you say, and it's going to be more to come. So what more can you say about your AI approach using neural networks? What about your hardware? Are you working in the cloud, or for the reason you just said, maybe more edge-based, facilitating your federated learning, supervised, unsupervised? Reinforcement learning will be one specific thing that I maybe come back to later. But what can you share with us there that is relevant to your approach?
Mm-hmm. So we're mostly working with neural networks, and then we use Bayesian optimization to optimize our recipes. We also do spatial modeling with VAEs and GANs. These are generative methods. In terms of the hardware, we do it two different ways. So we use the cloud for physics-based simulation. These are very heavy finite element analysis or molecular dynamic simulation kind of physics-based simulations. And the modeling and inference, we do it on the edge. And there's also one very interesting development that's happening in the field with analog AI and analog computing. That's something that we are also very interested in getting into as well.
I haven't heard about that at all. What should I think about when you talk about analog AI?
So analog AI specifically in this context is the ability to do these, let's say, calculations in the SRAM, basically in the memory. So not even using the CPU, GPU, but using SRAM.
Okay, so that is, as close, so to say, or central on the edge as it gets.
Absolutely.
Okay, good. One other thing I'm not aware of, you compared VAS, is that right, to GANs, VAS? What are they? They're a similar kind of algorithmic approach to GANs, or?
No, I said VAEs.
Oh, VAEs, okay, and still, what are VAEs?
So VAE and GAN, they're both, a generative method.
Okay.
VAE stands for variational autoencoder. So they're
okay.
Yeah, so they're quite similar in a way, but in terms of implementation, they're slightly different.
Okay, yeah, that would go too detailed for us here anyway. You haven't talked about your target audience, your customers. Feel free to share a name or two if you can. If not, that's not a problem. But at least, who are you targeting? So, being in Berlin, are you targeting European silicon manufacturing in the Munich area? I happen to be very close to one of them. I mean, we don't have that many. Or is that a global market that you can approach from? Doesn't matter wherever you are.
Mm-hmm. So we have 3 segments that we're targeting within the semiconductor industry. So basically, the production fabs, the equipment vendors, as well as the R&D fabs. So with the production fabs, we've already worked with Global Foundries in Dresden. So we already completed a paid proof of concept project with them.
Okay.
And then with equipment manufacturers, there are a lot of them here in Europe, actually. So you have ASML, you have other ones here, Extron. And with the research fabs, there are also a lot of them here, with Fraunhofer, with IMAC.
Mm-hmm.
And we're actually really lucky to be a part of the IMAC iStart programs. So we're working with them to come up with, projects, feasibility studies, and things like that.
Okay, yeah, we've talked about ASML a couple of times. Me, not because I'm Dutch. I was born not too far away from where they are based, Philips, right?
Uh-huh.
But more because we've talked about discrete manufacturing companies. I always need to be careful. Trumpf, which is not the same as the still president that you mentioned at the beginning, but Trumpf, which is the laser manufacturer component provider for ASML, and as well as Zeiss. And as I mentioned in the past, I had the opportunity to work with, I can't go into detail for NDA reason. But okay, so we got a little bit of a feeling then who it is that your customers are. Extending a little bit what I said in the beginning, or what you said, you're based in Berlin. Tell us a little bit about your team. You talked about the two guys, you and your Russian colleague that founded. Have you grown? What kind of people are they? Are they, data scientists like you? Are they people from material engineering? Yeah, share a little bit about it.
Yeah, so we're at 4 people right now. So we have recently onboarded a experienced, let's say, AI expert from the semiconductor field. So his name is Vadim. He used to work for Nanotronics, which is one of the best funded startups in the semiconductor field over in the US. So he's contributing a lot because he's very experienced in R&D as well as in the patent field. So he's providing a lot of that expertise to our company. The other guy that we onboarded recently is Patrick. So he's a PhD of physics from the University of Oxford. So he's helping us with a lot of the physics-based simulation stuff that we've been doing. And he also has a lot of expertise in photonics and 3.5 semiconductors. So these are the two areas that we have a very large interest in. So he's providing a lot of that expertise and competence to the company. So right now, the company is very much remote first. So Vadim is actually based in New York and Patrick is based in the UK. So we have people all around the world, but this also gives us an advantage because we have network in the US and we also have network in the UK, besides the ones that we already have here in continental Europe.
Sounds great. In the end, I'm going to ask you if you think that NVIDIA is going to be successful buying ARM, but I'll keep that to the end. One thing I forgot to go into more detail. If I'm taking too much time, let me know. We're only going to have a couple of questions on the case studies, and then that should be it. But reinforcement learning was a specific one that you didn't mention and probably don't use, but I'm just very interested in the technology as such. Specifically, as you mentioned, you come from material engineering. Now, I studied architecture in the Netherlands, and I have been sharing with our listeners that, we at that time we were pushing concrete, with huge machines until it would break. And then we see, okay, concrete breaks at whatever kind of Newton force, right? And then we know, okay, if we're now designing, it's always going to be to whatever max of 10, 20% of its force, the same with steel. Now, what I understand that these days, you can still do that, but you can use more and more in specifically material engineering, in designing new materials. You're going to give an algorithm like a reinforcement learning approach. You're going to give targets to say, this is my new material that I'm looking for. And then, RL, helps you to find in this huge space of capabilities, 1, 2, or 3 potentials, which then you as an engineer will work with. Is that something that you guys look at, or that because of what it is that you do as a company is not relevant to your approach?
So we're focusing on the production phase of semiconductor
Right.
manufacturing. But what you mentioned is actually quite interesting as well, because there is a company called Citron Informatics. They're based in Silicon Valley, and they're doing exactly that, using artificial
Okay.
intelligence for materials discovery. So maybe you can have your next podcast with.
No, that was a very good, just an answer confirming my understanding. Yeah, you say you concentrate on the production stage, and very good. Let's look at 1-2 case studies, and then we're gonna slowly close off. Maybe give us an overview, or go into 1 or 2 specific case studies, just to give us an idea of what it is that you specifically can do for your customers.
Mm-hmm. Yeah, one of the use case that we have is what we call the privacy preserving digital twin. So I already mentioned this a little bit. So the problem that exists inside the semiconductor fabs today is that a production line generally includes production tools coming from many different vendors. And even within a single process step, there are sometimes tools from different vendors. And they are very IP sensitive. So it's very difficult for a fab to optimize for the line level KPIs such as yield, throughput, without accessing these sensitive data from the vendors. So we use federated learning to help us to model these production lines, and so that we can do optimization on the line level KPIs across the different tools without exposing their IP. So being able to build a digital twin, but also preserving the privacy of the vendors. Another one of the use case that we have is for tool matching. So in semiconductor fabs, usually you have a fleet of production tools that are the exact same model. So, you see that in high volume manufacturing fabs, you have 4 or 5 of the exact same production tools, deposition tools or etch tools. And trying to match the hardware is very, very difficult, because it involves the constant tuning of hardware parameters by the technicians. And you also have to run these, what we call daily quals. Basically, you have to run the wafer and then see how this wafer look like after being processed by each of these production tools. So this is one of the reasons why it's very difficult to maintain a copy exact fab, because you have to constantly run these daily quals, and you have to constantly tune your parameters. So our approach is a little bit different. So what we do is, instead of trying to match the hardware, we try to match the results. So we use chamber-level digital twins to create automated localized recipes. So we allow the recipe to differ slightly, but this will allow us to tolerate the small hardware differences. But at the same time, we compensate it in the parameters to basically achieve the exact wafer results.
Sounds great. At the end, I'm going to ask you, where is this market going? I think you've been telling us a couple of new developments already, but where do you see this market in 3, 5, 10 years from now?
So semiconductor manufacturing is very interesting, because it's something that everybody uses, but nobody actually, not a lot of people actually know about it. And one of the most interesting aspect of it is that countries around the world, they are treating semiconductor as a strategic industry, and they're trying to obtain strategic autonomy and what we call digital sovereignty. And Europe is slowly realizing that as well, because semiconductor is so essential to the military, to intelligence, to supercomputers. Every nation wants to have their own semiconductor industry and be able to produce their own semiconductors. In the next 3 to 5 years, we are still going to see Asia, specifically Taiwan and South Korea, dominating the market, with TSMC and Samsung being the most significant ones. But here in Europe, we definitely realize that there is a deficiency, and that so recently there's actually a new development. So the European Union actually came up with a declaration to invest up to 145 billion in the next 2 to 3 years, with a goal of getting to 2 nanometer node. So this is an area that we are definitely catching up here in Europe, and we see US trying to do the same thing as well. With TSMC building a fab in Arizona. So there is a lot of political will to strengthen and to support the semiconductor industry. And with zero iteration manufacturing, we definitely think that we can contribute to the development of digital sovereignty here in Europe.
Thank you very much. Yes, because that means at my time, that's now, no idea, 15, 20 years ago, I recall the latest fab that I was part of. Intel building was in Ireland, I believe. That was 1 billion at that time. And I think today we're speaking, it's more like its own Moore's law, I guess. So we're talking more like 10, 20 billion for a new fab, right? So
absolutely,
I assume that whatever you can help to speed up the production, reducing the time to market, as you said at the beginning, will help. So resulting final question, you could prepare for it, maybe if you wish to answer it. So is NVIDIA going to be successful buying ARM, assuming that you have a good view on the global semiconductor manufacturing market?
Well, so this is a question that it's a difficult question. We're seeing a lot of M&A activities in the semiconductor industry. So recently we have Intel buying machine learning startups, and then we have companies, Lam Research buying up competitors. So, there's a lot of money in the industry, and these big players, they have a lot of capital. But for NVIDIA to buy ARM, I think there's going to be some political opposition. There's going to be some fear amongst, let's say, China and other developing countries, because ARM designs are used everywhere around the world. And to be monopolized, let's say, for it to be monopolized by one company, I think that's going to be very difficult to hear. And, even with Apple, switching to their Apple Silicon design, which is based on ARM, you see more and more, the ARM design is going to be very, very crucial to a lot of the newer developments. So it's going to be quite difficult for them to stomach that, unless there is, some kind of arrangement for it to be kind of like an open access or, a similar arrangement. But it's still very difficult to say.
Good. Thank you very much for that. Not really different. I mean, I was not going to expect a very clear yes or no on this. I think future will tell. Calvin, thank you very much for sharing your experience, your view. I hadn't been so close to it for quite some time. I'm sure that our listeners are going to be very interested in learning about exactly what it is that you do in that market space, and then maybe, one way or the other, use similar approaches in their own market. So thank you again very much.
Thank you so much for having me.
So, Peter, das war die Podcast-Folge Nummer 79 mit Semiconductor und KI. Ich sag vielen, vielen Dank für dein tolles Interview, das du mitgebracht hast. Ich freue mich auf die nächste Folge mit uns und wünsche dir alles Gute. Schöne Grüße nach München.
Schöne Grüße zurück, Robert. Das neue Jahr hat angefangen. Ich freue mich sehr darauf, für unsere Zuhörerinnen mit dir gemeinsam die nächsten, wie viele werden das? Richtung 40, 50 Folgen KI in der Industrie zu produzieren.
Tschüss.
Ciao.